to use. The problem when we get a vector or an equation of a plane,
It's kind of hard to talk about it.
we get something like this. That's the equation of a plane. Where's the vector here?
Somewhere in there.
Okay, so you pick out 1, 2, negative 3. What's the
Actually the normal.
the problem with that is that's the normal. It's not actually the
Negative 1 over.
negative 1 over. No. How do you? Does that work? How do you?
The inverse of a.
It's an inverse of a number. Yes. Is it the inverse of a vector?
Well, I guess.
Okay.
Sorry, they're reciprocal.
So I'm going to show you a diagram to help with this. So we need to think about the relationship in a right angled triangle. We need to think the relationship between this angle and this angle.
They're complementary,
Was it like the right triangle thing?
So, right. What is sine 60?
1 over 2. No, it's root 3 over 2.
It's root 3 over 2. What is cosine 30?
Root 3 over 2.
The same. Now, does that happen all the way through all angles? If this is 20, and this is 70, will sine
No. Sine 70 equals.
will sine 70 equal cosine 20?
No.
Check. Get a calculator. I'm not sure. I know the answer. I'm sure.
You are sure.
I'm sure. Yeah. You figure it out. Someone's got a calculator out here.
Oh,
Yeah.
Because it's like you're looking at the adjacent and the opposite, which are basically the same lines, just from different
Yes?
perspectives.
You guess.
But I couldn't remember all of them.
Sir, why
Oh,
are you
yeah,
doing the
yes.
sine theta one?
How does this help us?
It's the same.
So imagine that this is the vector equation and this is the plane. We don't have this vector.
Oh, you do the normal to the
We have this vector. So we have the normal vector. So this is the plane. This is the equation. We have the normal to the plane, easy got.
Yeah.
So we're going to use the normal to the plane. We're going to use the fact that the sine of this angle is the same as the cosine of this angle. The same, to get the same value. What's funny? Okay.
So one angle should be 90 degrees, right?
Yeah, but because we use the normal, we know it's 90 degrees. Normal. So there's a better diagram than this. Yeah.
What? Which one's the plane?
The plane is the.
The one I've marked is the plane. You can see maybe better on this diagram. So instead of using this angle, we can just say the same formula, but we can do it for sine. We'll get this angle. Hmm?
The angle between the line and the plane is different, guys? Well, yeah.
So the angle between the line and the plane we use the sine inverse, but we're not finding this angle when we do it. We're actually finding this angle. But the answer will be
Where to find that? Why can't you find that one?
Well, how do you do that?
we know they're in opposition. We know that they would add to 90 degrees, so one is the opposite. The opposite of the other. Sine and cosine are in direct, like reciprocal of the other, if you want to think of it that way. So they have to add to 90, and the ratios will also be the exact opposite. You know in your table, when you draw 30, 45, 9, or 60, when one is a half, the other is root 3 over 2, and vice versa. And they meet at 45 when they're the same. But it works for every single angle that are in oppositions. The cosine of 20 equals the sine of 70. The cosine of 10 equals the sine of 80. They're the same number. They get the same number. Okay.
As long as it's coefficient to 90 degrees.
As long as you have a 90 degree. Yeah, it's 90 degree.
You don't use the word coefficient.
Yeah, coefficient is definitely the wrong word to use there. Anyway, so this angle up here, which they called lambda, sine, not theta, sine lambda, because not the angle you're actually looking for, is going to be the same formula, but they rearranged it. So they want lambda is equal to sine inverse. They've already inversed that side, and it's, what letters they use?
Lambda?
I think that's what it's called.
Well, that's also the
Oh, it might be omega. Yeah, lambda is this one, isn't it?
That's like a lowercase.
Where?
How'd you draw that so? I thought the big lambda was like a
Oops. Omega, thank you. Omega.
Honestly, I thought it was a
Okay, so let's use that now. Let's get a question involved. Oh, actually,
It's like a straight line.
is it the same between two planes then?
Yeah.
What are we doing?
Sorry,
Isn't
what?
it like,
So this is the angle. This is the angle between a line and a plane. Next, I'm going to do the angle, and we need to think about this first before I show you the diagram, between two planes. What's the problem with two planes?
Well, neither of them are aligned.
You'll just get another thing like this. We get another one of these, and we don't have either direction vector. We can just get two normals. Yeah.
It's a 360 inside of the square. So if you find the angle between the two normals, it would be at 180 minus that angle.
So is the angle between the two normals the angle between the two planes?
Yes. No. They're perpendicular. So yeah.
Oh, you need have a little sketch. Have a little sketch. See, can you figure it out? Is the normal, the angle between the two normals, the two perpendicular lines to the planes, going to be the same as the angle between the two planes? So you got two planes that meet like this somewhere. Now I know they're three-dimensional, but it's hard for me to draw that. They're going to meet, two pieces of paper meet and will cross over at some stage.
Well, no.
What's the angle between those?
Any square postulates are that.
Is it the same as the angle between the two normals?
I don't think it would be because it's too perfect.
I know they'd be complementary. Like I know that. Like,
There's going to be something. There's going to be some link between the
I know,
two.
they're supplementary. They would
Oh,
have
no.
Are they supplementary? Are they complementary? Or are they the same? Do they add to 180 degrees? Are they add to 90 degrees? Or are they the same?
Supplementary, they add up to 180. Complementary, they add up to 90.
what do you mean that they meet up?
They add up.
Dude, sir, so they link like this, and you have 90 degrees here, and you have 90 degrees here, and then you have the bottom angle here, and the top angle there.
Yeah, you've got it. Okay, you were doing this. Yeah, you get a good. I think
The inside of the square is always 360. There's two 90
Yeah.
degrees. in
now
the
we have it.
square.
Here we go.
Okay,
Oh, I got
so plane one, plane two, like this diagram over here, they create this angle between the planes. Yes?
Yeah.
There is a normal to each plane. That's the thing we can get. That's the thing we can get easily. We can get the normal to that plane. Maybe I'll draw in a different color. So we want to find that angle, but we can only use the normals. So we have the normal to this plane,
I wasn't doing this.
and we have the normal to this plane. They will meet. We can get the angle between two normals.
That angle in that one, like where it's pointing.
Is it the same angle? Yeah.
No, it's not the same. But
Oh, can you get the angle here?
Well, like, then once you get that angle, you get the one in the middle,
Yeah, you get this.
and then the square thing.
Yeah, this one's going to be 180 minus that theta.
Yeah.
Yeah.
We know that because straight line. We know that that's a right angle and that's a right angle.
Yeah, then you'll find the angle.
So that means that one must be theta as well.
What?
Riz.
What?
Because these two add to 180. If this is 180 minus theta, that's a theta. Then this one has to leave theta.
Oh, okay.
Now there will be an angle on the other side here as well that they have included. But this angle is the same as this angle then. Which means the angle between, these are two normals. These are the two normals, remember in red. Normal 1, normal 2.
Parallelogram.
Then the angle between these two should be easy to find because we can read the normals off a vector, plane equation easily. Because we got the normal here, 3, 2, minus 6. Sweet, we got the direction of the normal. And then we can get the angle between them just using the normal. We don't have to think about the cosine. We just think about this. Don't think I have to think about the sine. You just have to think about the cosine. So, in short, the angle between the two, this theta, will be the cosine using the two normals. normal 1 dot normal 2 all over normal, the magnitude of normal 1 and the magnitude of normal 2.
I love angles.
Okay, let's do an example. So we got kind of the idea. It's all about finding the right two vectors to use. Let's talk about this style of one first.
Okay, this is line and plane.
A line and a plane. So we got this style of one first. I'll leave the formula up. So we're going to do the angle between a line and a plane. Notice the way we need the normal and just the direction vector of the plane. So if you're not sure what the n and d means here, the n is the normal to the plane, and the d is the direction vector of the line. That's the normal. You should be doing this to the plane. And this is normal to plane 2. So we have this formula to use. We're going to use this one. Hopefully.
Oh, isn't that was 1,
1, negative 1, 2 would be, yeah, that's correct. So in this particular case, we've got this plane. The question has a plane. X plus 2y minus z is equal to 8. And we have the equation of a line in our vector equation of a line in parametric form. We want to find, okay, what's the angle between this line and this plane? So we need two vectors that will work for us. The normal vector, our n, in this case, is going to come from the plane because we use the normal to the, and that's 1, 2, minus 1. That's n. And the direction vector of this one is using the coefficients of t, 1, minus 1, and 2. So we have our two vectors that we can use. Now we need to get the dot product. So we can start to fill in the angle, sine inverse. The dot product is 1 times 1 and the
1 minus 1.
Did you get it?
What? Dude, I just started the question.
Is the dot product?
No way, but so I don't want to.
remember the numerator is positive, even though it's sine, which we'll find.
Wait, n and d are directional vectors, right?
Yeah, n is the normal, so it's a direction, and no, shouldn't be that. Shouldn't be that.
What's the answer?
30 degrees.
30.
Yeah, 30 degrees.
What is it? It's 3 over...
What's
Your calculator might be in radians, if that's. So square root then 1 squared, 2 squared minus 1 squared is 1, 4, what, 6? Root 2 root 6s, I think.
Yeah, so it's just 3 over 6, it's 1 over 2.
Which is going to give 3 over
6. It's 1
oh, 3 over 6, which is a half, yes.
It is 3 over 6, yeah.
And so, what is it? Sine
6.
inverse? Is it cos inverse 1 over 2 or sine inverse 1 over 2?
Sine inverse. Sine inverse, yeah.
I don't think this was a calculator question.
Wouldn't it be like
No.
Wait, sir, why is it sine inverse though?
Is it 60 or 30 degrees, guys? I don't know my 30.
Because you haven't actually found, you found this angle. This is the line. This is the plane. You found this angle,
Oh.
which is the sine of this angle is the same as the cosine of this angle. So you got,
Okay.
yeah. So that's why we use sine for this one, because you're not actually finding the angle between them at all. You're finding an angle between the direction and the normal. This is the normal here. So you got to use that. Because if you use cosine, you wouldn't get the right angle. You'd end up with this angle. All right. for you, the second one is a calculator question. So in other words, the answer won't be a nice tidy decimal like this. You'll just have to use a calculator to get the inverse. But let's get that one. Oh, if we can. So the second one, we have two.
I was about to do the whole thing for N1, then I realized what the 90 degrees.
So I have this as my second. Okay. Plus 3z is equal to -1. Okay, there's my two planes. Let's find the angle between them by using the normals. This is probably easier. Well, it's about the same level of difficulty. So I need to get the normal to each plane, which I can just read off the coefficients.
And then you do that.
Yeah, normal 1 to this first one is going to be 1, 1, minus 1. Normal 2. Dot product, cosine
We're
inverse.
looking for like a cute angle.
Yeah.
Oh, we have to do 180 minus.
The answer is 72.
Wait, do we have to do 180?
Yes.
Oh, cool.
No, you don't have to do that.
Yeah,
This is,
Wait, are we on to the second question?
Yeah.
Sorry, I blanked out.
yeah, we're on the second question. So theta will be cosine inverse this time.
Oh, right, because I already did that.
So it's 1, 1 minus 1, and then 2 minus 1, and then I just do
So you have to take the
N1 dot
positive of that.
N2.
1 root 3, root 15. Okay, put 9, 10.
Is it not minus 2? No, it's just 2. It's 2 over.
It's root 14.
Yeah, it's root 14. So you in your calculator, it's 2. What's that? 2 over root 3, root 14. Cosine inverse, you should get 72 degrees.